In March 1979, two NASA space probes, Voyager 1 and Voyager 2, moved along a trajectory near one of Jupiter's moons, Europa, as part of the Solar System Exploration Program. At a distance of 118,000 miles from the moon's surface, Voyager 2 took a number of high-quality images and conducted measurements that led scientists to hypothesize the existence of a liquid ocean beneath the thick ice shell of the moon. All subsequent research, including the data collected by the Galileo space probe in the late 1990s while studying Europa at the height of 124 miles above the surface, only confirmed the existence of a liquid water ocean beneath the ice. The ice shell is between 6 to 18 miles thick. Soon, thanks to the space probe studying Europa, scientists were able to discover something that gave them solid grounds to suggest that life might exist on this moon. On October 14, 2024, NASA launched the interplanetary mission Europa Clipper. This spacecraft is set to travel to Jupiter's moon and conduct detailed studies of its surface and subsurface ocean. This is NASA's most expensive planetary mission in history, the largest space probe ever designed for studying a planetary body, and the most ambitious mission in the search for extraterrestrial life in human history. Europa is one of the 95 moons of the gas giant Jupiter, a mysterious cold world with a diameter of 1,940 miles, which is about 90% the size of our moon, entirely covered in ice. It's exposed to incredibly intense cosmic radiation and with extremely low surface temperatures that drop below -50 degrees Celsius. At first glance it may seem like a barren dead world, but currently, this icy moon is considered one of the most promising places in search of extraterrestrial life. In 1997, while following an extremely low trajectory just 125 miles above Europa's surface, the Galileo spacecraft managed to capture an extremely strange phenomenon. In one section of the moon's surface, there was something resembling a water vapor eruption. At the same time, scientists observed an anomaly in the readings from Galileo's magnetometer. Later, the Hubble Space Telescope, when studying the icy moon, provided new evidence of geysers on its surface. In 2013, it managed to take several photographs of the moon where it's possible to spot traces that were presumably left by giant geysers. Scientists believe that these geyser jets reach several hundred kilometers before crashing back down to the moon's surface. According to calculations, every 8 minutes there's enough water ejected from beneath the ice to fill an Olympic swimming pool. Indeed, there's plenty of liquid water out there. The depth of Europa's subglacial ocean may reach 60 miles, and the total volume is likely to exceed double the volume of Earth's oceans. It was recently established that Europa's crust rotation speed varies. Sometimes it moves faster, sometimes slower. This means that the crust movement differs from the speed of rotation of the moon's internal part. The cause is attributed to the gravitational influence of Jupiter. The tidal forces of the gas giant cause deformation, which makes the icy crust slowly and unevenly slide over the subglacial ocean. This creates a stretching effect, causing fractures to appear on the surface of Europa. Fractures that were first seen in photos shot by Galileo. Moreover, it's likely that the moon is heated from within due to tidal processes and friction caused by its flexing. Galileo also detected a strange disruption in Jupiter's magnetic field structure in the space surrounding Europa. This anomaly suggests that the magnetic field is distorted due to its interaction with an electrically conductive liquid beneath the moon's surface. Based on Europa's icy composition, scientists believe that the most likely material responsible for this magnetic signature is a global ocean of salt water hidden beneath a massive ice sheet, estimated to be about 10 to 15 miles thick. Any radiation or other external influence cannot reach this water world, which means that there is no threat to potential life and its evolution. But why do scientists believe that in such extreme conditions, far from the sun under a thick ice layer, it is nonetheless possible for extraterrestrial life to exist? We already know that liquid water is essential for life to emerge, and Europa has more than enough. Furthermore, the water on Europa is in constant motion, interacting with the silicate mantle, which means that mineral compounds are being washed away, providing resources for potential life forms. Thermal energy, which is another key component for life to exist, is present inside Europa due to gravitational deformation processes. Additionally, there are hypotheses that volcanic activity could be another source of energy. Examples of this exist on Earth, where volcanic rocks on the ocean floor interact with salt water, creating chemical reactions that generate energy and enable microbes, worms, and other organisms to thrive. Similar deep-sea vents might exist on Europa. The most important condition for the emergence of life is the presence of chemical elements, the fundamental building blocks for all living things. Just recently, the Hubble Space Telescope managed to detect carbon dioxide out there. Another astonishing discovery was made by the Juno spacecraft on September 29, 2022, while flying over Europa just 220 miles above its surface. It detected atomic hydrogen ions emanating from the moon's atmosphere, indicating a significant amount of oxygen production. This oxygen is produced as a result of radiation particles bombarding the satellite surface, subsequently breaking water molecules into hydrogen and oxygen. Researchers estimated that Europa produces around 12 kilograms of oxygen per second. Finally, for life to begin and evolve, it's crucial to have a stable environment and most importantly a vast amount of time, something Europa has had in abundance. According to the latest estimates, this ocean could have existed as long as our solar system, more than 4 billion years. If life does exist on Europa, what might scientists expect it to look like? It's believed that any forms of life discovered there would likely be primitive, similar to bacterial life that emerged from Earth's deep-sea vents. Others take it a step further, hoping to discover complex multicellular life. According to their hypothesis, something akin to chemotrophic bacteria might inhabit Europa's subsurface ocean, with other life forms feeding on these deposits, and there would likely be predators, possibly resembling sharks. Another compelling argument is one of the most significant geographical discoveries of the late 20th century. In 1973, a research expedition in eastern Antarctica discovered Lake Vostok, buried beneath 2.5 miles of ice and isolated from the outside world for millions of years. Water samples from this lake revealed the presence of unique bacteria. Conditions in Lake Vostok are believed to be not too dissimilar to those in Europa's subsurface ocean, giving us reason to believe that life could indeed exist in such seemingly dire and extreme conditions. In order to determine whether Europa's ocean could conceive and support life, NASA launched the most ambitious planetary exploration mission in human history, the Europa Clipper spacecraft. This is the largest space vessel NASA has ever sent to explore a planetary body. Weighing 122,000 pounds at launch, with its antennas and solar panels fully deployed, it spans 100 feet from one end to the other and is about 58 feet wide, larger than a basketball court. These panels are the largest ever developed by NASA for a planetary mission. Europa Clipper will need to travel a long distance, nearly 1.8 billion miles before it reaches Europa. The spacecraft will use gravitational forces of Earth and Mars to accelerate, expected to reach its destination in 2030. Europa Clipper carries 9 advanced scientific instruments on board, including radar designed to penetrate the ice, high-powered cameras that will map Europa with far greater resolution than previous missions, and instruments that will directly sample the surrounding environment. However, Europa Clipper may face serious challenges. Jupiter emits the highest levels of radiation in our solar system, excluding the Sun. To protect Europa Clipper, its electronics are housed in a storage compartment made of dense aluminum and zinc walls. The mission around Jupiter will last 4 years, during which Europa Clipper will make 49 close flybys of the icy moon, collecting all kinds of data to determine the exact thickness of Europa's ice shell and investigate its composition. As far as Europa, we'll learn whether its oceanic world under the ice is suitable for life in just a few years. But there's another fascinating world, Titan, the largest of Saturn's 146 moons, even bigger than Mercury. The gigantic moon is so similar to Earth it's almost hard to believe. Not only does Titan have lakes, seas, and rivers, but it also hides a subsurface ocean of water below the icy ground. In the moon's skies there are clouds, on its surface organics. It rains on Titan. Liquid bodies replenish lakes and seas and then evaporate, launching an Earth-like hydrological cycle. The atmosphere of nitrogen and methane is thick enough for you to safely stroll around its surface without a pressure suit. But that's only if Titan wasn't as cold as -290 degrees Fahrenheit. Because of the moon's low gravity, just 14% of Earth's, you would witness rain falling in slow motion, about 6 times slower compared to Earth. Although it would be no ordinary rain, it rains liquid methane. Titan experiences seasons of approximately equal duration, changing about every 7 Earth years. Just recently, the James Webb Space Telescope was able to detect clouds that form in Titan's lower atmosphere during late summertime, confirming that the moon has seasonal weather patterns. During equinox, occurring about every 15 years, enormous clouds of methane form in Titan's equatorial regions, bringing about severe windstorms. During the Cassini mission, scientists saw waves on Titan's lakes, 7 times taller than waves in Earth's oceans, but moving 3 times slower. Scientists have detected dune fields on Titan, taking up 13% of the moon's surface. Compared to sand dunes found on Earth, they are enormous in size, hundreds of miles long, 1.2 miles wide, and 330 feet high. There's more sand on Titan than anywhere else we know of. Although this sand isn't made of silicate like on Earth, instead it consists of solid hydrocarbons that fall like rain from the atmosphere. Scientists discovered that the moon has a special sedimentary process called sintering, where neighboring grains smash together and fuse into larger, stronger pieces. If sand on Titan can adapt in such a way to form complex landforms, could life have adapted similarly? According to researchers from Cornell University, it's possible for cell membranes to form in the conditions present on Titan right now, although they would have a completely different biology. But even if life cannot survive on Titan's surface, there's a subsurface ocean of liquid water hiding beneath the moon's icy coating. Scientists are trying to find out if organics can penetrate through this ice shell into the ocean, making this subsurface water potentially habitable. Soon we may find out the answer to these questions. Planned to be launched in June 2027, NASA's Dragonfly robotic helicopter will search for water or hydrocarbon biosignatures potentially present on Saturn's gigantic satellite. With Dragonfly's arrival, scientists hope to uncover clues about Titan's subsurface ocean, its potential habitability, and whether the ingredients for life might indeed be present in this distant world. If we discover signs of alien life on Titan, what might these otherworldly creatures look like? Thanks for watching.